Hi, everyone. Welcome to truthcourt.net, home of the Internet Court of Truth. The Internet Court of Truth and truthcourt.net are places where you can discover some more information about things you're reading or hearing on the internet or the media or anywhere for that matter. And the system is set up to work it's similar to a trial, a Western style civil trial. That means that there's a plaintiff and jurors, and in practice, you sign up, go to truthcourt.net and become a member. And then once you do that, you can go to the site and file a case, as it were, about something you've heard, and you would be the plaintiff in that case. So you would bring in a statement or a statement or a proposition or something you heard to trial, essentially. Once that's been done, you invite folks to be your jurors, and they would look at your claim or your statement that you're concerned with, and all of you and the jurors will answer 8 questions about the statement, and all of you answer the same questions, and afterwards then you'll be able to compare notes and see where everyone reads on that particular thing. It's a pretty simple process. You can share it after you've done a case. You can share it on your social media platforms. You can retry a case. If you decide you want to tweak it a little bit or ask different people's opinions, you can do that very easily. And just to let you know, we don't have anything to do here at Truth Court with what is in there. You guys, whoever you are, you men and women who are filing cases, you put the content in yourselves. We don't have anything to do with that. We don't influence that. It's all up to whatever anyone says as they're filing a case. Okay, so today I'm going to bring a case that is of interest to me, and I'm going to share my screen and show it to you. And we're going to take a look at what the Truth Court looks like. And there you go. You should be seeing now. And today's case is something that I find very interesting and have for a number of years. It's been around for about 30 years now. It's John Searle's Chinese room argument. And we'll get into what that is in just a minute. But let me point out to you here what you're seeing. You're seeing the case record screen of Internet Court of Truth. If you look on the left-hand column, you have a status column that tells you some things about what's going on with the case. If you look on the right-hand column, you see something here called verdicts. These are the 8 questions that everyone answers about the case. And in the middle is the details. And this is where, as the plaintiff, you present the information that you want your jurors to consider and act upon. Now, if we look over here in the left column again, we see I have 5 jurors who have accepted the role of juror. I sent them invitations, and that's very easily done, by the way, through the system. And 3 of the jurors have finalized their verdicts, and 2 are still working on them. So we'll go over what the case is about while those jurors are working on their verdicts. We're going to go to the central panel here, the central column, and that's called Case Details. The name I've given this case is Searle's Chinese room argument, and the category is that this explores what are potential weaknesses in something called strong AI, or strong artificial intelligence. Now, I'm going to go over here with you what this is all about. And here, if you notice, I expanded this accusation panel, and there's some data here, quite a bit of text that my jurors have read, hopefully, and they're going to read this and discuss something. And the thing they're going to discuss is down here, highlighted in blue. And we'll get to what all that is in a minute. All right, here's what the case is about. John Searle, a philosopher of mind, a philosopher of science, proposed something called a Chinese room argument. It's a thought experiment proposed by Searle, challenging the idea that a computer executing a program can truly understand or have consciousness. Now, this is a big issue in artificial intelligence and continues to be. I think it'll be debated for some time to come. Here's what the argument is. Here's the Chinese room argument. First thing, imagine a person, who we're going to call the person in the room, who does not understand the Chinese language, but's in a room with a set of instructions and in English for the manipulation of Chinese symbols. In that room, he also has filing cabinets and papers and pencils and other things that go along with the program of looking up things. The person in that room, the person in the room, received symbols in English. Okay, hang on for a second. Apparently, my accusation is not expanded. It looks expanded to me. Are you guys not seeing this all? Okay, well, here it is. So there's a person in the room who does not understand Chinese, but has a set of instruction for manipulating Chinese symbols. The person in the room receives Chinese symbols input from outside of the room. Has no direct interaction. Just someone slides under the door some Chinese symbols. The person in the room, following the instructions in English, manipulates the symbols that that person in the room receives and produces other Chinese symbols, which is the output, without actually understanding the meaning of the symbols. In other words, he's just following instructions. If you see this symbol, do this, this, this. So from the outside, it may appear as though the person inside the room understands Chinese because they're generating appropriate responses. Someone is inputting Chinese symbols and they're getting back out Chinese symbols. Searle argues, however, that the person in the room still lacks genuine understanding of Chinese. The entire process involves just manipulating the syntax, the syntactic manipulation of symbols, but there's no true comprehension of what the symbols mean. So Searle's conclusion is that merely running a program does not equate to understanding or consciousness. He contends that computational processes alone, no matter how sophisticated, cannot produce genuine understanding or consciousness without a subjective understanding of the symbol's meaning. The Chinese room argument is often used to challenge certain forms of artificial intelligence and computational theories of mind. What he talks about here is these two concepts of strong AI and weak AI. Searle's conclusion is that strong AI is probably not possible. Now, what is strong AI? Let's take a divergence just for a second and talk about that. Strong AI refers to the hypothetical concept of artificial intelligence that possesses general cognitive abilities comparable to those of humans. It implies the ability to understand, learn, and apply knowledge across a wide range of tasks, similar to human intelligence. So strong AI, artificial general intelligence, implies that a machine can have what is essentially human intelligence. Weak AI, on the other hand, is artificial intelligence that are designed for specific tasks. These systems are really, you see them all over the place right now. But we're not talking about that. What Searle's Chinese room argument is talking about strong AI. Now, there have been a number of issues raised against this argument. Critics of Searle's argument say that his understanding of computation is limited and doesn't capture the full scope of how systems can exhibit genuine understanding. Searle focuses on syntax, which is manipulation of symbols, but he neglects the importance of, or the argument, his critics say, neglects the importance of semantics. I don't know about that. I think that that's the key issue. It's a symbol grounding problem, focusing on syntax rather than semantics. Semantics requires interaction with the world to have meaning. Syntax is symbol manipulation. Searle is saying that's what programs do, manipulate symbols, but they lack semantic understanding. That's the symbol grounding problem. One of the other criticisms of Searle's argument is that the Chinese room argument focuses on the individual in the room not understanding Chinese, doesn't consider the possibility that the system as a whole understands Chinese. Well, there are really good answers to that argument. That one doesn't hold too much weight either. Then there's the criticism that it's a simulation of understanding versus real understanding. That's again saying that if the person doesn't understand Chinese, the system as a whole still might be capable of simulating understanding, which could be indistinguishable from actual understanding. That's a technical argument, and it might have some merit. And there are other issues here. Exclusion of embodiment of interaction doesn't take into account the embodied and interactive nature of human cognition. Critics argue that genuine understanding may emerge from interaction between an agent and the environment. And Chinese room scenario abstracts away from these aspects. Okay. And there are some other issues here. I'm not going to go into all of them. The absence of learning and adaptation, the appeal to intuition, inadequate treatment of functionalism, and people criticize the whole concept as being flawed. So I'm sure my jurors are going to bring all these points up when we talk about our verdicts over here. So we're going to jump over to them. But what I am asking them to consider today is Searle's conclusion, and I have it highlighted in blue here. And the conclusion is executing a computer program, no matter how sophisticated, does not lead to genuine understanding or consciousness. Therefore, strong artificial intelligence, which claims machine can possess true understanding, is fundamentally flawed. Okay, and if you notice, it's highlighted in blue. I have the option of highlighting it in blue or red or not highlighting it at all. Red means I don't think it's true. Blue means I think it's true. So I'm thinking it's true. Now, the whole notion of where all this came from, I got most of this from Wikipedia, but I also asked my jurors to read the Stanford Encyclopedia of Philosophy entry on the Chinese room experiment, which is quite comprehensive and very well researched and attributed all the various aspects of the argument. So they had the opportunity to read both of that. All right, so let's jump over here to the answers to all this. I see that we have some folks have already finished their answers. We have 5 jurors accepted, 4 have finalized, 1 is still working. So while that 1 juror is still working, I'm going to go over my answers. And these are the 8 questions that we're all addressing. Okay. Is it the truth? Is this statement in blue the truth? I say yes. It's pretty much the truth. I'm fairly confident, about 65%, that it's pretty much the truth. Despite the objections against his conclusion, reproducing the nature of subjective experience and the interiority of consciousness in an AI system is probably an insurmountable challenge, and from what I think. We're going to go, is it the whole truth next? And again, I'm answering, no, it's not the whole truth. Consciousness may not be reducible to computational processes, but that doesn't mean that we can't approach near consciousness in an AI system. So it's not completely true. I think there may be some wiggle room around it. Is it nothing but the truth? Again, I'm saying no. Humans are embedded and interact with our environment in very complex ways. Genuine understanding may require a level of engagement with the world that goes beyond the scope of current or maybe future AI systems. But again, maybe not. I'm not 100% certain of that. I'm only 65%, and that's a guess. So I think there's still some room where it may not be the truth. There may be more to it than this. There probably is. Okay, what is the deceit? Is there a deceit here? I don't think so. I think the statement is fundamentally true. Okay, I think the statement is fundamentally true. Even if AI systems have advanced cognitive abilities, there are ethical concerns and social implications about their desirability and the consequences of creating machines with true understanding. So I think this is fundamentally a true statement. That's my opinion. If the Well, I don't know. What do we need to do? Stop and reshare it? All right. All right, let's try it again. Whoops, wrong one. Sorry.
Well, you definitely you definitely restarted the share.
Okay. How about this? Are you seeing it now?
Yes.
Yeah, so you should be click on what I'm in like that.
I'm sorry?
You're click open one of the products. See if we can see it.
Okay, is that working? Is it sharing now?
Nothing happened when you clicked on the questions.
Nothing happened. It's not opening them up. Okay, well, I don't know what to tell you about that because it's doing it on mine. So this is a Zoom glitch, I take it? Um, okay. You want to, well, that's fine, I guess. I don't know. I think this is maybe fatally flawed for this case. You're not seeing anything at all here when I click on is the deceit or truth intended? It's not, which is working just fine here. Well, I guess I could go out and come back in, or somebody else could share. Why doesn't somebody else share? And
See if you could just go out and restart Chrome. I can definitely
I'm not on Chrome, but I'll restart.
whenever you're on. It doesn't
I'll
matter.
restart my browser. All right, I'll see you guys later.
Just a browser.
Best to see. I'm in Firefox and it was working. So,
Yours was working.
yeah.
So maybe
When this Zoom session started, I think I saw the same thing that Armor did that said that the session was unstable, but I never know if that's telling me that my session is unstable or if it's something more generic. But Armor and I saw the same thing when we entered the session. So,
Hey, I'm back here, so I guess I can try it again.
so is the
Okay, are you seeing the basic screen now?
Yes.
is
Click
that,
on one of the questions and
ah,
okay. All right, that worked.
Now it's working?
yes.
That works. Yes.
Okay. All right. Well, let me just start going over
one question? Are you on Firefox? What browser are you on?
I'm on the Mac
Safari.
OS. Yeah, Safari. Yeah,
Safari.
I'm on Safari.
Yeah, I tend to agree with Justin. This looks like a browser thing.
Okay.
Say on the right.
Well, at this point, I don't know whether it's worth going
No,
through.
keep going. It's good.
What's that?
Keep going.
Okay. Well, let me quickly run through them again. I'll run through my verdicts. Yes, I say it's the truth. Is it the whole truth? No, I say it's not the whole truth. That there were probably other issues involved. Is it nothing but the truth? Again, I say no. Humans are embedded in and interact with the environment, there may be other issues that involved here besides what Searle is considering. What's the deceit? I don't think there's much of a deceit. I think this statement is fundamentally true. That there may be, even if AI systems did achieve advanced cognitive abilities, could be some issues with that, ethical and other issues. Is the deceit or truth intended? I say yes. I think Searle and others who have worked on this issue intended to show that machine consciousness, if it is not possible, is at least highly problematic. What's the motivation behind it? The motivation is to explore the limits of strong AI and defend the uniqueness of human consciousness. So understanding may emerge from complexity of biological systems in ways that are enormously difficult to predict or replicate in artificial systems. So I don't know that that it's feasible to have an artificial system that achieves it. What's the social acceptability? I say it's acceptable. It's not only is it acceptable, it's probably a very good thing to be doing. And what label would improve that acceptability? In other words, if you saw this blue statement here, what would it, and wanted something to explain it, what would it be? My answer is the statement may be true, but valid objections have been raised to its conclusion. And there are other people who have worked on this very issue, and it's not a new concept. If you would read the Stanford Encyclopedia of Philosophy entry on the Chinese room experiment, you can read about Leibniz's mill and Turing's paper machine that similarly consider this issue and come up with similar conclusions as did Searle. All right, so I'm just going to, at this point, bail out and ask anyone who wants to make a comment about this to jump right in and do that. And if you want me to share your answer, I'll be happy to. So go for it. Anybody want to say anything? Bob, you probably do.
Yeah, I have. So this is the a very old and sad event in AI and computer science years ago, where for some reason that a lot of people could not understand, the people thought the computer was just what we were building then, and they didn't understand the computation. So I tend to agree with that first comment that came back. Searle completely misrepresents what forever has been meant by computation. It never was the the PC of the day or the mainframe of the day, the CPU or the memory system or the storage system or a Turing machine or any of these things. And so I think what he's talking about is what we call an early version in a von Neumann machine, which is the thing that everybody learned to program with these serial steps. And there were a lot of people that were experimenting and actually building things where you didn't program with serial steps, so they were still computation machines. In fact, one of the biggest areas of research was how do you organize parallel computations, because it was so obvious that the human brain, and you could prove it, was a serial parallel computation device. What the ears are doing, for example, what the eyes are doing, the neurons in the ears are doing, what the neurons in the eyes are doing, are operating parallel. There's no sampling mechanism mechanism that says, okay, well now listen for I don't know, frequency 1,000. Now let's go to the eye and let's look for on cone 7,632 what its RGB readings are. Now let's go back to the nose and figure out what whether or not it's smelling cinnamon. Now let's go back to the ear and check and see if it's going over it. So that kind of thinking was not taken seriously in the world of AI. It was obviously not right. Okay. And people like Searle turned it into something like it was the fundamental thing that we were doing. When it was the fundamental thing that they could buy was a serial programming machine because that's what they could build at the time. But that's not what we were considering. And we've actually seen this in modern AI, ChatGPT, the transformer stuff, where once you hit a certain amount of parallelism, the computations can be very, very simple, but it achieves unbelievable intelligence, which is apparent intelligence in terms of this. And that's exactly what we've always been talking about. No change in the AI world, except for some marginal AI people that never really understood. But the people like, even the people who did general problem solver like Bill and Simon, I knew them. They did understand. Okay. And in fact, if you look at the symbol manipulation stuff that Simon did, it was very intelligent on how he was operating the, how he thought of computation from an AI perspective. And what they were doing with the things like the general problem solver were working with a subset of the control system that was emergent out of the general computation system, which should be general intelligence. And Searle just never ever got that. He never understood any of it.
Yeah, but Bob, it seems to me that Searle's point is not whether or not you can have a sophisticated enough computational machine that it simulates for all practical purposes human intelligence. I think the point, and he was a philosopher, not a computer scientist. I think the point is that is a representation of intelligence the same as understanding. And is understanding necessary for consciousness? And if we're talking about general AI, are we talking about something sophisticated enough that based upon our perspective, the answers are right and it looks like intelligence, but A, is it intelligence? B, does it matter? I think that's a valid question.
So I agree with that, but I guess what I'm saying is that he's right for a serial processing computer in a technical sense of a serial processing computer that executes one instruction at a time. I think his argument is a very, very strong argument that you'll never achieve general intelligence that way. Okay. Particularly intelligence that looks even remotely human. Okay. It just won't. I think that argument, the way he's making it, holds water. Okay. But if you go beyond that and look at so there's always been two types of AI people. One type was trying to compute like the brain computes, the human brain computes. And those people rejected this serial processing model. The other group was an engineering group that said, well, given what we've got for computers, can we get them to be really intelligent? Okay. And that engineering group that's where Searle was coming from. And the answer is he's right. I think his argument holds a lot of water. So I think that there's but the idea that that because he's right for the serial processing model of computation does not mean that he's right for general AI. Okay, because and he's never been right for general AI. No, the general AI people have never, ever, to my knowledge, actually sure that believed that a machine built it like a wholesale serial processor would ever achieve general intelligence. Nobody believed. They believed that you could get some really interesting results out of like the GPS stuff or the general problem solver stuff from Newell and Simon that shows how human intelligence can be applied in formal ways to discover some things that are difficult to discover without the serial processing machines. So anyway, so that's my argument is that in modern terms, now that we've demonstrated what happens when you have a trillion variables and this emergent intelligence, you're actually seeing what we saw 40 years ago. We were pretty confident that we were on the right track, abandoning the serial processor computation model. And that's proven now, I think, proven for sure that that confidence was well founded. Sorry. Leroy, did I address the thing that you wanted me to, or did I talk off of it?
Well, I heard what you said. I'm not so sure in my mind that you did, but I totally accept the notion of the change, the way we're now building these language models and what way beyond the context that he was in. But I think my verdict, what I said was, well, you sort of had Bohr's model of the atom, which we reject now. But at a certain level of abstraction, it works just fine for explaining lots of things. And I kind of looked at Searle's presentation, limited as it is, and it doesn't hold up in the modern context. I don't think Searle would make the same statement today that he made back then, but from a kind of a philosophical point of view, this notion of simulated intelligence versus understanding, I think that's still a valid argument today. I mean, for instance, I've been reading research where they talk about they're watching in some of these large language models what looks like inference that based upon no inputs, new inputs, but simply the generative AI looping through, it seems to come up with relationships between things that had to be inferred. They weren't based on the inputs. And so the question is it thinking? Is that inference something that the model has been able to do on its own? The answer that comes back when I read it is, well, these large models and these huge networks that have been built are beyond our understanding. We have to use other AIs to go back and just see if we can understand how that happened. So we're in this gray area where we go, well, oh no, is it actually doing inference, which would be a very important step towards understanding? And the answer is, well, guys, we really don't know because they're too sophisticated for us to understand even now how they're actually working. So to me, I think it's having that philosophical framework of Searle understanding consciousness intelligence around the question of what's happening with the AI is valuable from a human social perspective, valuing AI, making decisions about how we're going to use it. Very interesting. So I see it as still having tremendous value, even though it's dated.
I'd like to make a
I
couple
think
comments.
the Bohr model is a really good analogy.
Can I defend my?
Really is kind of thing.
Let me make a couple comments, please. First of all, it's not all that dated. Searle and others have been, as recently as a year and a half ago, still commenting and publishing. There have been hundreds and hundreds of papers published on this. It's still a very lively debate. It's not outdated. I mean, maybe the technology has changed, but the concept hasn't. That's my first point. And the second point I want to make is that the important thing here is, in my mind, the difference between syntax and semantics. Syntax is symbol manipulation. And Searle's point is that computers are going to have a very difficult time getting beyond syntax because semantics requires interaction in the real world, in culture, in the culture and the real world experience. And until we actually build robots that go out and interact into the world, which we might, syntax is going to be what computer computation is limited to. That semantics is a subjective thing, and by very definition, it's not going to be available to computational devices.
So yeah, so there's so the uh, from the perspective of people who operated under the parallel computation assumptions, we actually distinguish the language, for example, you can distinguish between what are called paradigmatic and syntagmatic relations. So in semantics, usually that translates into what's called substitutability. So can this symbol substitute for that symbol in certain contexts? Okay, that defines the semantic domain for the symbol. And if you look at the surface structures of language, and you think about how language evolved, in other words, English evolved and continues to evolve with time. French evolved, and natural language itself evolved over time, over many years. What would naturally occur is the syntagmatic and paradigmatic relations among words at the surface level, i.e. words, will it start to embody intelligence?
I think you're trying to substitute semantics for, you're trying to reduce semantics to syntax. And I think that's a
substitutability is not
understanding.
Syntax is order. Substitutability is no order constraints whatsoever. Okay. But what you expect is that a system that's trained on surface, in other words, predicting the next word, given the word, what the third word will be, and so forth and so on, will show intelligence, but the intelligence that's built into the language,
Yes, right.
into the language, not intelligence that was built outside of the language.
Right. Right.
And that's the way to work. And that's what we're actually observing is that, for example, these systems are very, very good at being convincing and saying things that are incredibly nuanced and with a lot of inferences that are being made on one or two, but are terribly bad at telling the difference between the truth, between stuff that's factual and not factual. That's actually a consequence of what I just said. Okay, you expect that. And so what we're seeing right now is the large language models have a great difficulty in actually being able to do what people can do with with tools for thinking about things outside of the language itself, okay, outside of what's built into the language. How language actually is used literally through corpuses, these giant corpuses that represent the training sets, and out of which things like the whole paradigmatic syntagmatic structural linguistics was built. So there's a whole domain of linguistics called structural linguistics, out of which all this stuff comes. And and I'm aware that there are philosophers of science that are still stuck in these old models, and you know, and are still getting papers on them. But the newer models are looking at this and going, you know, we can't really, for example, you can't look at the output of a single neuron in the brain and tell what information is traveling over that output, that synapse. You just can't.
Armor, are you agreeing with Bob? I think you were starting to there.
No, I very much agree with the idea that the semantics that we see, apparent use of semantics that we see in the large language models is based on an incredible database of how language is actually used. And those corpuses are carefully selected and probably entitled in various ways. I mean, we can ask ChatGPT to do a poem about a cow in a pasture, and it probably in its database somewhere we have these sort of meta labels about this is a poem, this is a story, this is an argument, and they make very good use of those patterns which are recognized and labeled and used. So it is. I completely agree that currently the semantics that we see in the large language models is based on an enormously extensive base of knowledge about how language is actually used. And so when Bob says semantics is embedded in the language, it is embedded in that sense.
That's exactly what that's exactly the way I mean it. It's embedded in the use of the words, the way people are using them.
But you yourself said that the words change, that the use of the words change.
I said that. I didn't say I said that language is constantly.
Computers are not going to know that unless they're told, unless they're trained on these very large databases.
Right. Yeah, these large databases, large database models.
They're always going to.
People complain about them because they're trained in 2019 or something. They say they don't know about blank, which is a new concept that the appeared in English in recent times, and they flood those words. They don't get them because
And it depends on the language in which they're trained as well.
every language grows all the time.
Because there are things that are not translatable from
Well,
language.
and
Translation.
if in fact we're implying that all of the semantic value in these large language model is what's implied by the use of the words in the language, I have a thought experiment. My thought experiment is, let's take any domain of knowledge. So we narrow it down. It could be physics or chemistry, or pick something. Now, read all of that into an AI. Our AIs are all really biased towards English. So do it in English, then do it in German, then do it in Chinese. Now, ask all three of those the same question and have them simulate the intelligence for their answers, and then look at those. I suspect they would be quite different, even if you used exactly the same AI infrastructure, the same tensor processing units with the same parallelism.
Trained on different databases, is that what you're saying?
Yeah, well, they wouldn't be identical because the English information that you would consume versus the stuff in German or Chinese isn't going to be identical. Even though it may be about the same information domain, they're not going to be the same. So I suspect that, but if you had an English and a German and a Chinese person in that domain start discussing their ideas through common languages, I think something would happen in the interaction there to arrive at a consensus view of reality that they're able to do because of their ability to handle the semantics from their human experience and to infer and imply things and to communicate back and forth to get to some sort of consensus understanding that might not be achievable with the artificial intelligences trying to, get to the same point. So I think there is something about the semantic from the human experience and the semantic implied in the language models that is different. That's how I see it. And I think this notion of intelligence and understanding and consciousness and semantics all tie together, and that from Searle's perspective. So anyhow, I still think that there's a lot of room to converse about this notion of artificial general intelligence and understanding. I think understanding is the key. I think it's perfectly possible to simulate human intelligence about almost any question you could ask a human being in the machine, and we will get to the point where the machine will be able to generate the answer that the human would generate. But is that intelligence? And is it understanding? Intelligence, maybe so. Understanding, maybe not.
And the argument from my side would be, since these large language models are trained, exactly what I said, to predict the next word, that's what they're trained to do. They use the corpuses to predict the next word, essentially. That's exactly what they do. If they're translating, it's predicting the next word in German, for example. So, but by the way, what I don't know if y'all have noticed this, but these large language models do translation among a lot of different languages. But one of the really big complaints is for a lesser used language, the people who speak that language say that these large language models do lousy jobs in translations. Just to be clear, okay? They don't. There's nothing about them that's doing anything other than what they say they do, which is predicting the next word. They're just big statistical process.
In my experience, all these language translating things are pretty good at simple concepts, open the door or something like that, but they fail. All of them fail pretty badly when it comes to nuance or those kinds of things that are more subjective. they just
The
don't
sort
get
of connotation, the emotive connotations of words, and what a particular culture regards as a standard way of taking off from a word and forming metaphors and analogies to other things.
right.
And if it's not the training set, and it's outside the basics of the language that would get reflected in all of the training sets, then yeah. And in fact, so part of the trick that OpenAI figured out, which is transformer stuff, is to train in physics, for example, you have to have essentially physics templates that the prediction is also trained into, okay? Which or another one is to tell stories, you need to have a narrative structure that things are trained into. In order to, the corpus has to be classified with respect to this is how this piece of the corpus fits within the narrative, structure. You can't train without those general
Categories.
yeah, and so that's the but what's being said, I think that is really important here is that the language itself embodies, if it's in the corpus and the corpus is properly labeled, it can pick up on things that are apparently very nuanced, but are not going to get there are not going to get to fully human intelligence until it gets beyond just what language can carry, or just what labeled pictures or labeled movies can carry. It's got to go beyond that and be able to invent its own reasoning systems, for example, so on, outside of anything that we've ever seen before. And we're really not seeing that right now because we have nothing to train on. You know, I mean, we don't know how to do that computation. We know how to do this word for word prediction or make a picture look really interesting, unique, and beautiful, but we don't know how to go beyond what Chomsky would call surface structure. But surface structure contains a lot of intelligence, which is what we're seeing. It's just, not the intelligence. But it's not to say that we're not going to get there, which is what Searle's argument is. If you think in terms of parallel computation, we see nothing stopping us other than the practical limits of the hardware and the training sets.
All right, very good. Interesting discussion.
We went pretty far down that.
Yeah, sorry the case was such a disaster, but the discussion was. All right, guys.
Okay.
And we'll see y'all.
See you next week.